Okay, so here's an example of a short but satisfying mathematical proof. I call it the accordion proof. Anyway, so this is called the basic summation formula, and it basically says that if you add together the numbers 1 plus 2 plus 3 plus 4, etc., all the way up to a certain natural number n, then the sum of all those numbers is n times n plus 1 divided by 2. Okay, how the heck do we know that's true? Well, let's prove it. We start by writing out the numbers we're adding up from least to greatest, starting with 1, 2, 3, etc., and ending with whatever the three biggest numbers are, which we will write as n minus 2, n minus 1, and n. Next, we're going to systematically simplify this expression by combining the first and last numbers, then the second and second to last numbers, then the third and third to last numbers, etc. But notice that each of those pairs adds to the quantity n plus 1. So we're really just taking this long string of added numbers and squeezing it down into a bunch of n plus 1s added together. That is the quantity n plus 1 times something. Now, what is this something? That is, how many n plus 1s did we just make? Well, it depends on whether n is an odd number or an even number. If n is even, then that means we're adding up an even number of numbers in the first place. So when we pair off those n plus 1s, we can pair all of the numbers together with no extras. And we get exactly half as many pairs as there are numbers, naturally. So if n is even, we would have 1/2 times n plus 1, which does in fact simplify to the formula we were trying to get. Now, if n is odd, then when we pair off those numbers, we're going to have one number left over. Specifically, the number in the very center of the list. Well, this means that all n minus 1 of the other numbers in the list were able to be paired off as n plus 1s. So we have 1/2 times n minus 1 times n plus 1 for the pairs, and then plus something for that mystery number that's left over. So how do we write this mystery center number in terms of n? Would it just be n divided by 2 because it's like at the halfway point? Well, let's think about that. Think about the number 5 as an example. When you list out the numbers 1, 2, 3, 4, and 5, what is the center number? 3. It's not 5 over 2, or exactly half of 5, because that's 2.5, so not a whole number. Instead, it must be 3, which is the next whole number bigger than 2.5. So in general, when adding up the first n natural numbers, where n is odd, the center number is always going to be n plus 1 divided by 2. It's sort of like taking the next biggest even number from what you started with and then cutting that one in half, and that's how you get to the center number of the odd number. So adding those two expressions together, the 1/2 times n minus 1 times n plus 1 for the number of pairs that we have, plus the mystery center number written in terms of n, when we add up both of those expressions together to get the total, we still get the formula n times n plus 1 over 2 by simplifying. QED, we are done. And that, my friends, is the accordion proof. I made it that whole time without moving the board, and then I moved it while I was erasing it. Oh well.